Hello, and welcome back. In this video, we will be looking at Docker and a few examples of how to use Docker and what is it used for. Bear in mind, just want to say before we get started, Docker is quite vast. There are lots of literature on Docker available to you. This is mainly for a light introduction and explanation as to what this is. And if you've never used Docker, this hopefully you find this useful, and maybe even you get a chance to try one of the examples. So to give you a bit more tangible understanding of what it is. Okay, let's jump straight into the shell. So Docker is an open source platform that enables developers to build and ship and run applications in isolated environments called containers. Containers package an application and its dependencies together, and you ship that package in the form of an image. What that does, it ensures consistency. Traditionally, you would have something like a virtual machine, and in the virtual machine, you would need to install all the dependencies, pre-configure the machine, orchestrate, provision that machine with all the dependencies and libraries needed. But in that case, you're running an entire operating system on a virtual machine. That comes with its overhead, and that's also not as agile or quick to spin up compared to a Docker container, which some of the key features of Docker is that Docker is lightweight. Containers share the OS kernel. That means the Docker containers themselves don't have an operating system on there per se. It shares the lower level operating system, which gives it the opportunity to be very flexible. You can bring them up quickly, you can bring them down also fairly quickly, which makes them faster, more efficient, and much more faster than a virtual machine. It's also portable. The containers can be run anywhere you have Docker installed, and Docker is available across all the major platforms. So more or less, if you put something in a Docker image, that will become a container that can be executed anywhere. It's scalable. You can spin up as many containers as your environment would allow, and that could improve performance of your website or your application per se, or your processes, whatever you're using the containers for. You will benefit greatly from having the ability to scale up. So let's jump in and look at a basic example. So let's clear this out, and now we're in the shell. I will start by looking at the Docker help. If you want to get stuck in, you go Docker, not Docker, and -- help is a good place to start. So within the Docker help, you can see there are quite a bit going on. But one point I want to make about the Docker help, which I find quite useful, is very contextual. So at this high level, this is the first level menu, you will see a list of all the commands that you can call. For example, Docker run. We'll use Docker run today in this demo. It's one of the most used command. It's at the top. It's the first one you need to get your head around. But more or less, they all are of similar value. But for example, just to demonstrate how contextual this menu, the help menu is, if you should say Docker run and then -- help, now this will take you one step lower and looking at the help specifically for the run command, which is great. So because of that, I don't think you get a man page with Docker per se by default. You can download them, but they're not there by default because the help is so comprehensive. The help is quite useful and it's contextual to the specific commands that you're running. Imagine if you had to put all of this help in one file, it would just be a bit much to search. So it's quite a good idea because of how vast the features and capabilities of Docker is. So that's the help menu. So please visit the help menu, have a look around, see what you can understand, drill down into it, and you will get a good amount of knowledge from that. So the next thing, now we talk about Docker, images and containers. So there is a distinction between the two. I know sometime a developer might call an image a container and a container an image because of fluency, and within the team everyone understand what this means and no one, but there's a clear distinction between the images and the container. An image is analogous to when you have a image for an operating system that you will install on a virtual machine. But seeing that Docker is a bit lightweight, it's not as heavy as a full-blown operating system, but it has elements of an operating system. It has capabilities that should be sufficient to run whatever processes or application you are trying to get up and running. So one of the things that I look at is how can we run an image? Or how can we run a container which is usually instantiated from an image. So an image is more or less the blueprint that you outline, you create an image, and you save that image. And whenever you want to start a container, that container is based on that image. And you can make as many containers as you like from that image, but the image remains as is. And if you change that image, you can then spawn new containers from that image with additional changes. So let us try to run a basic hello world container. So say Docker run, come on, spell right. Where's my keys? Hello world. I think this container, this image, I'm sure it's like that. So now this is a basic Docker container that is hosted on Docker Hub. It's been there forever. It's one of those test test image that we use to spawn containers. Now, if I should do this, let's see what happened. So I'm telling Docker to run that container locally. Interesting. You can see, let's go through this output. So the first line is unable to find that image, the latest version of that image locally. So instead, it went out and pulled that down from the Docker Hub library, which is great. That's what you expect. That's one of the power of Docker. If it doesn't find the specific image that you're trying to base your container on, it will go out, fetch that image, and then build your container, instantiate or build your container from that image. Now that seems successful. Went out, grab it, download complete, followed by a message output saying hello Docker. So that's all that this container does. It outputs a line, hello Docker. Now we've successfully run and built a container. Now, can we have a look at my list of images I have stored locally? I'd go Docker image list. That should list all the images that I have on my local machine, local cache. You can see I only have one, and that is the one that just got pulled in by the docker run command that did not locate this on my system. So I went out, pull that. From now on, if I ever want to run, if I do docker run again, you see that this time it just runs. It didn't need to go and fetch it because we already have a copy of that. So that's one of the efficiency of Docker. You pull an image in, and that image will be reused to spawn multiple containers without affecting the image itself. Hope that's clear. The next thing I'll demonstrate to you is, let's run a more substantial container, and let's hop into that container, log into that container, and have a look around, and maybe get some shell access to that container, and do some basic operations as if we're working in a remote system. So in this output, you can see here it says docker run it ubuntu bash. Very important stuff. So we're going to run this command because you said to try something more ambitious, you can run a ubuntu container with this. So we already understand the docker run. This I'll explain. The -i means interactive, and the -t is a tag. So this is going to, and the tag is Ubuntu, so it's going to look for an image with that tag. It's going to run that image into it's going to create a container based on that image. It's going to execute that container, and it's going to execute the bash command, while the -i indicates that it is going to also keep it in an interactive state so you can enter additional information within the command line. So let's see that in action. I think we can just lift this from here and run this. Let's see what we have. So if we run that, okay, you can see exciting stuff. It's gone out. Latest. Unable to find it locally, so went ahead, pull it in, similar to what it did, and it's download the image, then it spawn a container, and you can see how that works. Now you can see I'm actually logged into that container interactively because of the -i in that command. I'm in the container and I can do things. I can go ls, I can do top, and top will list the processes on the system. You can see there are only two processes running within this container. Bash itself, the one I started the container with, and top there. They're moving around. It's ordered in CPU usage or something, so it's gonna keep reordering. And top being this very tool that's displaying this. So you see how lightweight that container is. It's only running the things that we want it to, which is very good for efficiency and reducing overhead. On a standard virtual machine, there will be lots and lots of processes running on the machine that are essential to the upkeep of the machine that you cannot terminate, and they're also in some cases resource intensive. So that's also something we need to think about, as well as the security side of the virtual machines. If the virtual machine become vulnerable for whatever reason because of the numerous packages on the virtual machine, then your whole application is at risk. While a container can be destroyed and respawn, it's isolated. And not to say Docker is more secure, but it's because it's isolated, you can control what goes on in that container. You can restrict access to that container significantly more than, say, a host system with lots of processes beyond your control. Okay, so we can see that in action, and let's exit out of the shell and go back to our base OS system. That would be done by exit, and we're back to a normal system. We've closed the container off and we are out. And just to list the number of images we now have, I expect 2 exactly. So we load in the Hello World because we didn't have that. We load in the Ubuntu because we didn't have that. So now going forward, if I should create a container based on any one of these images, it should just work. And it wouldn't need to re-download the image. All makes sense? Excellent. Let's go to the next thing I'd like to talk about. So, just one more tiny demo. And for example, the next use case that is more widespread is, for example, if you have your own application and you'd like to get a container packaged up into a container, into an image that will become a container, you now need to create your own Docker file to create that image, build that image, and then you can distribute that image or use that image as your blueprint for future containers. How do we do that? To get started, you need a Docker file. If I go, I did prepare a simple Docker file with 3 lines, just to keep it simple, the bare minimum, so you could get some understanding of what this means when someone say Docker file. Okay, so if I should open that Docker file, in that Docker file we only have 3 lines, which makes it very easy to understand. The first line does an extension. It's a common practice in Docker for the from command to be on the first line, and that from, because of how you build up your Docker images, you in many cases you start with an existing image and then add your changes to that image as you go along and freeze that into a new image going forward that someone else can also extend if they choose to. It's very extendable, and that's what makes it so cool. So in this case, we are going to be building our image based on Ubuntu, and followed that, the second line is the command. Once you instantiate this image and copy Ubuntu, we are going to run these commands in our new container. We're going to be running apt-get update, which is the package manager for Ubuntu. So we're going to update all the default packages. Apt-get install -y. We're going to install a package called Cause to do a little experiment. Followed by line 3, cmd. We are looking at user games Cause. The application we install here, we know exactly where it's going to be by default. So we are going to use the command directive to execute that Cause, followed by the message that the Cause application will display. So Cause is a small ASCII art application that will print out a small ASCII art of a cow saying whatever text you pass to that function. Should we see that in action? So now we've created a Docker file, and Docker files can be very complex. They can have multiple layers, lots of things, but this was kept simple so we can get through it quickly, the bare minimum. Now, what we need to do, we need to now build this Docker file into an image. And let's see how we do that. So go Docker, and we'll have build, not buildx, as something else. Let's take some of that out. So Docker build, and I think we could do Docker build tag it as my say, and I want to give it the current directory. So if you'll be looking in the current directory for my Docker file, which is in this current directory, that denoted by the dot, and I will build this image and I will tag it as such. So in the future, if I want to create a container based on this image, I have a tag to reference it by. Shall we go? That's looking good. That looks very zippy. So it's gone through and it's built a new image. And let's list all our images and see what we have stored. If we go Docker image list, you can see we have lots of images now. We have 3 images. We have the hello world we started with, Ubuntu we pulled in, and now we have my say. And should we now test out this the created image by creating a container based on it? Let's do that. Let's go Docker run, and if we just say Docker run my say, I can also give it a T just for it to pick up that tag. Exactly, look at that, lovely stuff. It did work as expected. It ran the container, it executes, and it says my say and got out. So that is exactly how it would work in practice. As well, you can now pass back the -i if you want it to be an interactive shell. But in this case, I just want the Docker container to output hello Docker. And that's about it. Thank you for watching. Hope you find that useful as a lightweight introduction into looking into Docker. This should be a gateway for you to go off and do further research. Have a look at the online documentation. Watch a couple more extended YouTube video. But I deliberately slow things down here so you can get on the train, get on the ride, and get an understanding of what it means and what is Docker used for. Thank you for watching, and catch me in the next one where we look at additional tools. Thanks again.